These are the Algebra 1 8.4 notes, only going over example 1. So in section 8.4, we're learning this new format right here. This is called vertex form. All right, so vertex form of a quadratic function is this: f of x equals a times x minus h squared plus k. So this is vertex form. So in here you have this h. This h moves the graph horizontally, like left or right. And then out here you have this plus k. The k moves the graph vertically, meaning up or down. So that left and right movement and the up and down movement change the vertex. So the vertex comes from the numbers where h and k are. And the axis of symmetry, of course, is x equals, and it always equals the x value of the vertex, which in this case is h. All right, so in example 1a, it wants us to graph this function, compare the graph to the parent quadratic function, find the vertex, the axis of symmetry, and describe the domain and the range. So this 3 is a vertical stretch by 3. The minus 1 is a right 1. And the minus 6 is outside, so that's vertical, and that is down 6. So remember that on the horizontal inside, when it's minus, it's right. When it's plus, it's left. Those are on our transformation sheet. So because we go right 1 and down 6, you can see our vertex right here is at 1, negative 6, which makes sense because you see right 1, down 6. Our axis of symmetry is going to be x equals 1. Our domain is going to be all real numbers. Let's go ahead and graph it first before we finish the rest of this. So since we know that our vertex is 1, negative 6, we can go to a calculator and pull up a table, and we can plug in just to the right of 1 would be 2 and then 3. So we can use our calculator to plug in 2. And so try that, just plugging in. What I would type in my calculator is this, the entire equation, or I'd go to my table, I'd type in the equation using x, and I'd just pull up what x is 2. All right, so that's going to make negative 3. So you have 2, negative 3. And then when you plug in 3, like I said, you can either type this in, or you can just go to your table and look at 3. And I believe you're going to get 6. So then if you have your axis of symmetry right here, once you have the right side, you just reflect over to find the left side. And you can now see that our range, since it opens up, which we knew because the a value is positive, its y is greater than or equal to, and the number there is negative 6. That's always the y value of the vertex. Okay, so on this one, you can see there's no number in front of the parentheses, so there's no vertical stretch or shrink. This plus 2 is left 2. The plus 3 is up 3. So since we go left 2, the vertex is at negative 2, and up 3, the y value is at positive 3. So if you graph that left 2, up 3, that makes sense right there. Now, the a value is this number right here. Since this number is positive, it opens up. We know that it equals 1. It did not have a stretch or a shrink. So you could sit here and you could go ahead and make a table and plug in those x values. Or the other way you can do it is, since there is no stretch or shrink, you know the shape from the vertex is over 1, up 1, back to the vertex, over 2, up 4, back to the vertex, over 3, up 9. Or if that does not make sense to you, then go ahead and just pull up a table on your calculator. All right, it does open up, which we knew because our a value is positive. So it's y is greater than or equal to 3. All right, so on this one, the 1/2 is the a value. It is positive, so it opens up. It has a vertical, that would be a shrink, because 1/2 is between 0 and 1 by 1/2. This plus 4 is left 4, and then the minus 2 is down 2. So left 4 is negative 4, down 2 is negative 2, or you can just count on your graph left 4, down 2, and you see it right there. So the axis of symmetry is at x equals -4. I know since it opens up, it's greater than or equal to, and that's always the y value of the vertex. To find your other points on this one, since it does have a vertical shrink, I would probably just start by plugging in numbers just to the right. So like you could do -3 and -2. I'm actually going to opt into doing those two. You could also just pick evens because you see they're going to be divided by 1/2. So we're going to go to our calculator and we're going to plug this in. And let's see here, when we plug in -3, we end up with -1.5. So that's right there. And then when we plug in -2, we end up with 0. And here's our graph. So on this one, this is reflect over x-axis. So that tells me it will open down. This is right 2. And since there is no number out here, it basically did not go up or down any. So it went right 2, and then it did not go up or down any. So it's at the vertex of 2, 0. And you can see I find the vertex right here. I use this number instead of -2, I use +2 because of how horizontal translations are always like opposite, like minus is right. And then this is the k value, and I use 0, so it's 2, 0. I get this is h, k, and that makes the vertex. So the axis of symmetry is x equals 2. It opens down, so it's less than or equal to, and then you put the 0 there. And now, once again, you can make a table and find the other points, or since it did not stretch or shrink, you know it has that shape where it goes over 1, up 1, over 2, up 4, over 3, up 9, except it opens down. So it goes over 1, down 1, back to the vertex, over 2, down 4, back to the vertex, over 3, down 9. But if that does not make sense to you, just make your table.